KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss two example problems. So next continuing example problems, those are example 7.8 and example 7.9. Okay. So in our previous class we discussed principle of movements and then center of gravity. Okay, right. So while discussing about principle of movements, we discussed the important physical quantity, that is what mechanical advantage. So mechanical advantage is very important in our daily life, right? When we are handling, when we are doing some particular work, mechanical advantage is very, very important. That is what there itself we have written in terms of forces and distances. That is, mechanical advantage is equal to F1 by F2, that is equal to D2 by D1. F1 by F2, that is equal to D2 by D1. Okay, that is what. Afterwards, in case of center of gravity, I already told, center of gravity is an imaginary point where the total weight of an object supposed to concentrate, right? So while constructing a ship, while constructing a sports car, while constructing a huge crane, whatever it may be the vehicle, not only a particular vehicle. So whether it is moving on the road, whether it is moving in air, whether it is moving on surface of water, so whatever it may be, while constructing a vehicle, right, definitely we have to keep in mind where is the position of center of gravity, right? Sometimes we can see the tilting of either the vehicles or the buildings, right? So the type of situation occurs because of unbalancing of the forces and because of the shifting in the position of center of gravity. Okay, there may be some other physical reasons. I am not talking about physical reasons. I am talking about the importance of center of gravity, right, which helps us to get the stability for an object, right? So whether it is in whether at rest or in motion, stability is important. No, for example, the ship is going and it has to take huge luggage from one country to another country. The journey time will be months, like 6 months, 3 months, right? And 1 year, like that. No, so it's anyhow. What I want to say is there is so a lot of time the ship has to stay in ocean, right? So when it is transferred from luggage from one country to another country, okay, that and all, but what I am saying is, the stability of ship is important. When it is in the ocean, right, that is what the floods and the hurricane and the movement of water, right? So many things will come into the picture now. So these are all the things the ship has to bear. Similarly, the sports car also, right? So the sports car means generally it has to travel with high speed, that is what, like 200 kilometers per hour, right? And 250 kilometers per hour, 300 kilometers per hour, like that. Okay. right? The road is nice, you know, if the road is not nice, it is not possible. I am not talking about the physical conditions, but the role of center of gravity, the role of center of gravity, right? So when the vehicle is moving with that much of speed, you know, the tilting and the accidents and the skidding, these are the very important factors we have to overcome. So this and all gives the stability, right? Even in business point of view also, if one new model of car came into the market, means if it is not stable, if it is giving the continuous, that is disturbances like accidents and skidding something, you know, that model will fail, right? The business person will get loss. So I want to conclude only one thing, the topic of center of gravity is very important while designing and while constructing ships, because it belongs, it related to the stability of a vehicle. Related to the stability of a vehicle, or simply you can say that stability of an object. Okay, right. So center of gravity is an imaginary point where the total weight of an object supposed to concentrate. Okay, and yesterday in the previous class, in the previous class itself, you know, we learned how to find the center of gravity. How to find the center of gravity in case of irregular shaped object, right? Suppose for example, if we imagine irregular shaped cardboard, right? So for that cardboard, how to find the center of gravity, that we discussed like a small experiment, okay, right. Thereafter, okay, that's what. So in our previous class, we focused on principle of movements and center of gravity, okay, right. And next, you see here, it is what next continuation to the topic center of gravity. Here this is one example problem. Example 7.8. Example 7.8. See here. A metal bar 70 centimeters long and 4 kg in mass, supported on two knife edges like this, K1 and K2. Placed 10 centimeters from each end. Placed 10 centimeters from each end. So from here 10 centimeters and from here also 10 centimeters. 10 centimeters from each end. Okay. A 6 kg load is suspended at 30 centimeters from one end. A 6 kg load is suspended at 30 centimeters from one end, full stop. Find the reactions at the knife edges. Find the reactions at the knife edges. Right. In the bracket, what they have given? Assume the bar to be of uniform cross section and homogeneous. Assume the bar to be uniform cross section and homogeneous, right? So this assumption is compulsory to go when we are going for calculations. You know, the assumption is compulsory, right? The mass is distributed uniformly, right? And it is homogeneous, right? That is what he is saying, right? So if you look at the problem, a metal bar of 70 centimeters long and 4 kg in mass, supported on two knife edges, placed 10 centimeters from each end. A 6 kg load is suspended at 30 centimeters from one end. Find the reactions at the knife edges. Okay, here that is what R1 we have to find, and we have to find R2 also, right? R1 and R2 we have to find. Okay, see here. See this, no? So this picture, so whatever we drew and whatever they have given, right? We can also draw, no problem. See here. The rod AB, the position of the knife edges K1 and K2, comma, the center of gravity is G. So he is saying about the picture. Right. The rod is uniform in cross section and homogeneous, right? Hence, G is at the center of the rod. You know, when we were in a discussion about the center of mass at the starting of this class, or you know, in previous class also, I reminded you how to find the center of mass and center of gravity. Okay, anyhow, center of mass depends upon the distribution of mass particle. Okay, you just put aside, because here the topic is center of gravity, right? Even yesterday, previous class, we discussed how to find the center of gravity for a given object, right? So there we discussed for irregular object. Okay, right. I told you, I reminded you, in case of regular object, now the center of gravity coincides with geometric center. In case of regular object, the center of gravity coincides with the geometric center. That is what? Okay. Center of gravity coincides with the geometric center of an object in case of regular bodies, right? So here rod is also regular body, no? That's why the center of gravity is at its geometric center. So whatever the center is there for physical portion of the rod, so that is the center of gravity. Okay. So according to the given information, AB is equal to 70 meters. According to the given information, AB is equal to 70 meters, and AG is equal to 35 centimeters, and AP is equal to 30 centimeters, right? And AP means already they have given, that is what a 6 kg load is suspended at 30 centimeters from one end, right? That is what AP is equal to 30 centimeters, and AG is equal to 35 centimeters means, just now I told you, in case of regular object, in case of regular bodies, center of gravity coincides with geometric center. If the rod length is 70 centimeters means, so according to the geometric center, and because of uniform distribution of mass, that is what uniform in cross section and homogeneous, we can say that the center of gravity is 35 centimeters from one end, no? Similarly, from other end also it is 35 centimeters. Okay, right. So AP already given, that is what 30 centimeters. And when it is 35, that is from A to G is 35 and A to P is 30, then what about PG? PG is 5 centimeters. PG is 5 centimeters. Okay, right. Then next, AK1, right, BK2 is equal 10 centimeters. Already given. That is what here, which is knife edges placed 10 centimeters from each end. 10 centimeters from each end, right? So AK1 is equal 10 centimeters and BK2 is equal 10 centimeters, and K1G is equal to 25 centimeters, and because it is 35 now, it is 35 now. So when it is 35 centimeters and it is 10 centimeters, it is 25 now. So K1G is equal 25 centimeters and K2G is equal 25 centimeters. K1G is equal 25 centimeters and K2G is also equal to 25 centimeters, right? Also, weight of the rod is 4 kg. He only mentioned that, right? He only mentioned that the weight of the rod is here, 4 kg. Okay, kg means mass, right? Weight means you have to multiply that mass with G value, that is what. Okay, right. So weight of the rod is 4.00 kg, and afterwards if you see that weight of that is what W is the weight of the rod. I want to say the notation also, and W1 is the suspended load, weight of the suspended load, that is 6 kg. Okay, right. And next, R1 and R2 are the normal reactions. R1 and R2 are the normal reactions of the support at the knife edges. R1 and R2 are the normal reactions of the support. Here, this is what R1 is here and R2 is here. R1 and R2 are the normal reactions of the support at the knife edges. At the knife edges. Okay, right, full stop. And now, so these are all they have given. Just we are writing by using the notations and by using the symbols like AP, AG and K1G, like that. See here, for translational equilibrium of the rod, so to keep the body in translational equilibrium or for the rod itself to be in translational equilibrium, this is the equation which has to satisfy. That is what R1 plus R2, right, and similarly minus W1 minus W is equal to 0, right. And by using these symbols, that is what plus and minus, you can decide what is vertically upward direction and what is vertically downward direction. And moreover, for our convenience, I put the arrow marks. See, R1 and R2 are acting vertically upward direction, W1 and W are acting vertically downward direction, okay. So that R1 plus R2 minus W1 minus W is equal to 0. This is the equation should satisfied by the rod to be in translational equilibrium. That is, for our convenience, it is equation number 1. Next, for considering rotational equilibrium, here we take moments of the forces A, convenient points to take moments about is G. For considering rotational equilibrium, we take moments of the forces. And afterwards he is saying that a convenient point, right. Here A means not a point A, it is what English letter, that is what a convenient point, that's what, okay. A convenient point to take moments about is G. Right. The moments of R2 and W1, are anti-clockwise. This is what R2 and this is what W1, right. The moments of R2 and W1 are anti-clockwise, that is what positive. Anti-clockwise means positive sign convention, that is what. Whereas the moments of R1 is clockwise. Okay, right. Okay, so how can we write the expression or condition for rotational equilibrium? See this. For rotational equilibrium, minus R1 into K1G plus W1 into PG plus R2 into K2 into G. So it is what PG, K1G and K2G. So this is the expression you can write for rotational equilibrium. Okay, this is like equation number 2. Okay, we have some values they have given, right. So by substituting these values in equation number 1, by inserting the numerical values in equation 1, we can write it as R1 plus R2 minus 4G and minus 6G. I told you to find weight, we have to multiply the mass with small g, that is what acceleration due to gravity. In this problem we are taking it as 9.8 meter per second square. Okay, so it is minus 4, it is minus 6, minus 4 plus 6, minus 4 minus 6 means it is minus 10. And if you take this minus 10 to that side, then R1 plus R2 is equal to 10.00. Okay, right. So 10 G newtons. And if you substitute the G value, that is 9.8, then you can write it as 98 by 10 and it will get cancelled. So finally, R1 plus R2 is equal to 98 newtons. R1 plus R2 is equal to 98 newtons. Okay. It is equation number 3. Okay, right. So it is equation number 1, it is equation number 2, it is equation number 3. Okay. By substituting the given values in equation 2, okay, that is what? Minus 0.25 R1. See here. So what is K1 into G? Is 25 centimeters, no? 25 into 10 to the power of minus 2. So to convert into meters, no? So it is minus 0.25 R1 plus 0.05 W1. 0.05 W1 and PG PG is 5 centimeters now, that you have to convert into meters ma, then 0.0511 plus 0.25 R2 is equal to 0, okay, right. And from this is what like okay, right, or from this, that is what R1 minus R2 is equal to R1 minus R2 is equal to, okay, it's okay, it is like equation number, it is ma, from 2 we got this one, that is what minus 0.25 R1 plus 0.05 W1 plus 0.25 R2 is equal to 0. And you know the same thing we can write like this, that is what R1 minus R2 is equal to 1.2 G newtons, and if you substitute the G value, you will get it as 11.76 Newton. R1 minus R2 is equal to 11.76 newtons, okay, that is like equation number 4, right. From 3 and 4, R1 is equal to 54.88 newtons and R2 is equal to 43.12 newtons. R1 is equal to 54.88 newtons and R2 is equal to 43.12 newtons, okay. So these are the values of R1 and R2, okay. Thus the reactions of the support are about, you know, it is 55 newtons at K1 and it is 43 newtons at K2. Thus the reactions of the support are about 55 newtons at K1 and 43 newtons at K2, okay, that's what he is asking to find, okay. So this is all about example 7.8. he is asking to find reactions at the knife edges, okay. For seeing it is big, but here we did just we have written the given values to avoid confusion clearly, and here we are getting 3 equations, right. So here we are getting 2 equations, right. From first equation we are getting third, and from second equation we are getting fourth, right. From third and fourth we are getting the values of R1 and R2. Next, see the next problem, that is example 7.9. A 3 meters long ladder weighing 20 kg leans on a frictionless wall, full stop. Its feet rest on the floor 1 meter from the wall as shown in the figure, right. Find the reaction forces of the wall and the floor. Find the reaction forces of the wall and the floor. Find the reaction forces of the wall and the floor, that we have to find. So we have to find reaction forces, okay, right. Next answer, see this. The ladder AB is 3 meters long. The ladder AB is 3 meters long. They have given, that is what, a 3 meters long ladder. And its foot A is at a distance AC is equal to 1 meter. See the picture also, ma. AC is equal to 1 meter, right. So here when AC is equal to 1 meter, that is what according to that given information, that is what here they have given, ma, which is that weighing 20 kg and find the frictionless, see this, its feet rest on the floor 1 meter, its feet rest on the floor 1 meter from the wall as shown in the figure, and you observe carefully. So what's the figure is, okay, and afterwards he is asking to find reaction forces of the wall on the floor, okay, right, see here. And you know, you see the answer, the ladder AB is 3 meters long, its foot A is at a distance AC is equal to 1 meter, at distance AC is equal to 1 meter from the wall, okay. From Pythagoras theorem, it is like right angle triangle, no, it is like right angle triangle, okay, right. So if you see this picture, from this picture, that is what, by applying Pythagorean theorem, you know, BC is equal to, see the picture, ma, BC is equal to 2 root 2 meters, BC is equal to 2 root 2 meters. Okay, that is what hypotenuse square is equal to side square plus side square is there, no, like that. And afterwards, if you see the forces on the ladder, if you see, this is the ladder, no, it is the ladder, it is the wall, and it is the floor. Okay, right. And you know, this is our contact force, and it is also contact force, that is what normal force, right? And it is the force F2 and it is the force F1, and here is the point D. Okay, and this distance is 1 meter already given. This we found from Pythagorean theorem, that is 2 root 2 meters. Okay, right. And you see this, the forces on the ladder are, so what are the forces on the ladder? Forces on the ladder are its weight, that is weight of the ladder, weight of the ladder. And okay, the weight of the ladder is acting at its center of gravity. You know that center of gravity is an imaginary point where its total weight supposed to act. Okay, and reaction forces F1 and F2, reaction forces F1 and F2 of the wall and the floor. This is because of wall, ma, this is because of floor. Okay, right. And F1 is perpendicular to the wall, you know that, you can see the picture. Okay, and the wall is frictionless. F1 is perpendicular to the wall since the wall is frictionless. Okay, right. You know, F2 is resolved into components. F2 is resolved into components. So what are the components? What are the components here? One is, so see that picture, and if you are seeing the component of the forces, right? If F2 is resolved into two components, one is the normal reaction, ma, and another one is force of friction, capital F here. So F prevents the ladder from sliding away from the wall and is therefore directed towards the wall. So this F, so which avoid that sliding of the wall. You know, if the sliding of the ladder from the wall, right? So this is what. Suppose if the ladder is sliding, means how can we climb up, right? It is not possible, no? Okay, right. And now we are going for calculation. First, you see that for translational equilibrium, taking the forces in the vertical direction, right? For translational equilibrium, taking the forces in the vertical direction means n minus w is equal, it is n, it is w, n minus w is equal to 0. It is like equation 1. Next, taking the forces in the horizontal direction, taking the forces in the horizontal direction. So there you can write it as, it is F, it is F1, F minus F1 is equal to 0. It is like equation 2 for our convenience. Okay, so it is what equation number 1, it is what equation number 2. Okay, next, for rotational equilibrium, taking the moments of the forces about A. So this is the A. So if you take the moments of the forces about A, then you can write it as 2 root 2 F1 minus 1 by 2 into W. 2 root 2 into F1, 1 by 2, this is what 1 by 2, 1 by 2 into W is equal to 0. It is like equation number 3. Now, what is W we know, which is 20 G. So, 20 is the mass, no? 20 is the mass. So, G means we are multiplying G means to get weight. So, 20 G means it is 196 newtons, okay? Right. So, from here, from this point, you can find out, you can go for equation 1, 2, 3 again. From equation 1, so W is equal to 196, no? From equation 1, N is equal to 196. N is equal to 196. And from 2, that is what? Okay. Okay. First, you see from 3. So, what is the 3? 2 root 2 F1 is equal to 1 by 2 into W, no? W is equal to 196, no? So, it is 98, no? So, 2 root 2 F1 is equal to 98, and so that you can find out what is F1, which is 34.6, which is 34.6 newtons, right? You just get this, here you just write down this value, W value, and then you will get it as F1 from equation 3, that is 34.6 newtons, right? From 2, so where is the 2, right? So from 2, F is equal to F1, no? Already we found F1, so F is equal to F1, that is 34.6 newtons. so that you can find F2. This is F, it is F1, it is F2. So that you can find F2. F2 is equal to square root of F square plus N square, that is 199 newtons. 199 newtons. Okay, right. The force F2 makes an angle alpha with the horizontal, right? The force F2 makes an angle alpha with the horizontal, right? So that is what here, for example, we are assuming that the angle is alpha, right? Afterwards, tan alpha is equal to n by f, right? So it is opposite side by adjacent side. It is n by f, that is equal to 4 root 2. So then what about alpha? Alpha is equal to tan inverse of 4 by root 2, that is approximately equal to 80 degrees. That only he is asking, no? What he is asking, no? First he is asking find the reaction forces of the wall and the floor. Okay, we also found the angle alpha, right? That is what F2 makes with the horizontal. F2 makes with the horizontal, that is what approximately equal to 80 degrees. Approximately equal to 80 degrees. Okay, right. So in this problem, in the second problem, this problem is important even in our NEET syllabus, right? In our for our NEET exam also the same problem. This problem is called as generally ladder wall problem, right? So the same problem is important, right? So you focus on 7.8 and 7.9. So regarding the equilibrium, that is what the rotational equilibrium or translational equilibrium, these two problems are important. Okay, right. So in our next class we will continue with next continuing topic. Thank you.